Let's go ahead and review day 1 of our textbook. So this is lesson 5, day 1, operations and scientific notation. Make sure you're reviewing this after you've attempted to answer these questions. So our question today is evaluate the following expression. So if I was looking at this and I wasn't trying to answer letters A through E, I would either, you have two choices of how you're going to answer this. You can either change both. Your first option could be to change both add-ins to scientific notation, or you can change both add-ins standard form. Okay, so that's really up to you. All right, so today we're really just going to focus on keeping them both in scientific and standard form. So 950,000 is already written in standard form, and we know that because it's expanded and it doesn't have a power of 10. What form is 4.6 times 10 to the 7th power written in? It has both a coefficient and a power of 10. And when it has both like that, it lets you know that that is written in scientific notation. Okay, and we go ahead and move on to number C, or to C. Write 4.6 times 10 to the 7th in the same form as 950,000. They have 4.6, our coefficient, they left it alone. Then we need to change 10 to the 7th to its standard form. So 10 to the 7th is equivalent to 10 multiplied by itself 7 times. And all you do is multiply that out. So you'll have 1, 2, 3, 4, 5, 6, 7 zeros. 2, 3, 4, 5, 6, 7. That's 10 million. Now all you'll do is you'll multiply your coefficient by 10 million. So you should have 46 million. And what you need to do is you need to make sure that you are correct. All you'll need to do is go back to your coefficient, and your exponent actually tells you to move your decimal place 7 places to the right. So move it 7 places to the right and see if it's the same as what we got. 1, 2, 3, 4, 5, 6, 7. Add in your placeholder zeros, and you should have 4, 6, and then 6 zeros. And that is exactly what we have, so we are correct. D, write the original addition expression with all numbers in standard form. So now let's rewrite this one. Our 950,000 is already in standard form. So we have 950,000 plus 4.6 times 10 to the 7th power. We rewrote that and said that it's equivalent to 46 million. So we'll go ahead and write that here, 46 million. Okay. And they said just the expression, so we don't have to solve it right now. E says explain how you would simplify your expression. What's the sum? All we would do to simplify this expression now is add the two numbers together. And so we'll do that. Let's go ahead and I'll put the larger number on top and my smaller number on the bottom, lining up my digits, and just add. And I find that my answer, or my sum, is 46,950,000. All right. So that's it for A through E. Let's go ahead and move on to the next page. Find out more. When you add very small or very large numbers expressed in standard form, it can be difficult to keep track of all the zeros and make sure the numbers are aligned by place value. One way to deal with these problems is to express each number in scientific notation. So the other way, remember we talked about you have two choices. You could either write all of your numbers or both your numbers in standard form, or you can write them both in scientific notation. So you could change 950,000 to scientific notation. So we would have 9.5 times 100,000. 100,000 is the same as 10 to the fifth power. Then what we would do is we'd go ahead and move on to the next part here. So remember that there is a link between place value and the powers of 10. Before you can add numbers in standard form, you must align them by place value. Likewise, before you add numbers in scientific notation, each power of 10 must have the same exponent. That is so important. So before you add numbers in scientific notation, each power of 10 must have the same exponent. So what they ended up doing is they changed 4.6 times 10 to the seventh power to make sure that we, so they broke apart, I love how they did this. They broke apart 10 to the seventh power into 10 to the second plus 10 to the fifth, because we knew we needed a 10 to the fifth here. So they made sure that one of our factors was 10 to the fifth power. Well, 10 to the fifth power times 10 to the second is equivalent to 10 to the seventh. So then they regrouped, and they had 4.6, which is their original coefficient, times 10 to the second, and that was 460 times 10 to the fifth. So now we have our common term. Now that both numbers are expressed with the same exponent, you can find the sum. So we have 460 times 10 to the fifth plus 9.5 times 10 to the fifth. So then we can regroup again, just pulling out our common factor, which was 10 to the fifth power. And then we just add 460 plus 9.5. So it's 469.5. And then what you would need to do is you then put it back in scientific notation, where our coefficient is a number between 1 and 10. So 469.5 does not fit that bill. So you'll have to move your decimal place right between the 4 and the 6. And in order to do that, that means if we moved it over 2 places, that means we've divided by 2 to the 10th power, or 10 to the second power, which means we need to do the inverse, which is times 10 to the second power. So this is what they've done, and I probably said that in like a really jumbled way, but I'm really happy that they have all of the steps written right here. This is very important. All right. So let's go ahead and go to the reflect question, which is our exit ticket for today. Again, I hope that you've already reviewed or tried this on your own before you review this. All right, Paul says that 3.14 times 10 to the fifth plus 2.53 times 10 to the fourth is equal to 5.67 times 10 to the fifth. Is Paul correct? And explain. So we're going to use, you can either go and put both of these numbers in scientific notation, which they already are, but make sure they have the same power of 10, or you can put them both in standard form. What I would like to do is I would like to go back to what they did here, and I'd like to apply that to a new problem. So we want both of these numbers to have 10 to the fourth power. I'm just going to go down. It's easier to go down than to go up to make it bigger, so let's just do that. Oh, well, you know what? Yeah, that's what I'm going to do. And they said that, so I'll just do that. So we'll have 3.14 times 10 to the first times 10 to the fourth plus 2.53 times 10 to the fourth. All right. So then I'm going to regroup. So I'll have my 3.14 times 10 to the first, and then my times 10 to the fourth, plus 2.53 times 10 to the fourth. Okay, so then I know that 3.14 times 10 to the first, that 10 to the first is telling me I need to move my decimal place 1 place to the right, and that'll be simplified. So I'll have 31.4 times, so that's what all that is, times 10 to the fourth. Now I have both of them as 10 to the fourth. All right, so now that I have a common factor of 10 to the fourth, I can actually just distribute or factor that out. So I have 10 to the fourth multiplied by 31.4 plus 2.53. So I'll go ahead and add those off to the side. Okay, so once I add them, I get 33.93 times 10 to the fourth. But again, I need to put this in scientific notation. So I really am saying that I have 3393, and I just moved my decimal place 4 places to the right to standard form. I want to put this number in scientific notation. So it's really going to be equal to 3.393 times, and since I've done that, to get from 3.393 back to my number, my answer, then I want to move it 1, 2, 3, 4, 5 places to the right. So I multiply by 10 to the fifth power. This is my solution, the actual solution, but this number, and I'll change it, this is the number that Paul got. Is Paul correct? No, he is not. And he's not because this is all of our proof. Okay? Please make sure that you've written all this in your textbook as well. And that is all for day 1.